All right, so welcome back. Today we're going to finish up on database design. We're not yet done with the module since we do still have to talk about database connectivity. It won't take the entire time to wrap this up, but I will take some time at the end to review what the post that I made over the weekend on design on the Java design. But in any case, let's go ahead and finish off with database. We were looking at database design. Let's talk about what's called normalization. So normalization, there are basically three normal forms that you need to worry about. There are additional normal forms that go beyond this. They're theoretical or have to do with like temporal databases, stuff like that. The three normal forms are what you need for the vast majority of relational databases. And so we abbreviate them, say one normal form, a two normal form, and three normal form. And these build on each other. So if you, to be three normal form, you have to be two normal form, and to be two normal form, you have to be first normal form. So if you violate any of those below, then you automatically don't have the third normal form above. So first normal form is pretty easy. The statement is that each attribute, a column or a field in a database table, has only atomic values. Right? Now, what do we mean by atomic? Well, we don't mean like we don't mean it in the sense of atoms, but that atoms and the original word of atom. The original word of atom, atom, meant indivisible, right? Something that is basic, that it's atomic, right? We know, of course, now that what we call atoms are actually divisible, right? They're made of quarks and a bunch of other stuff. And of course, you could divide atoms and blow them up in nuclear reactions. But we mean atomic as in the old original, say Greek or whatever it was, way of atomic, that indivisible. It cannot be, that you cannot cut it down any further. In other words, every column in a table holds only one value, right? And it's much easier to understand these things when you look at what would violate these things. So a violation of first normal form would say be having comma delimited storing comma delimited values in a single column, right? So for example, emails. I can have one email. We represented this in the CSV file was, of course, a bunch of comma delimited values. But that's because it's not a relational model. It was a flattened file. That's how we had to represent it. But in a database, if you stored that first email, comma, second email, comma, third email as one big giant string in one column, that's a clear violation of first normal form. There's a relationship there. There's a one person to many emails. And once you've got that relation, you need a separate table, and you need to relate those tables through foreign keys. It would also be technically a violation to store a fixed number of values. For example, email 1, email 2, email 3, right? And we saw several people do this in their Java code itself. Instead of defining an actual list or a collection of strings that represented emails. Now, that's not a huge violation. The first one is definitely a huge violation. The second one is not so much of a violation if you have a use case for it. For example, why would we need to store 50 emails per person, right? Granted. You could have a primary email and a secondary email, and that's all we want to support. In that case, you might have an argument for saying that, okay, we're only going to have two fields. Both of them can be, the first one can't be null because they have to have an email in this system. We have to be able to contact them somehow. The secondary email, that's optional. So we'll make that nullable and allow them to enter that if they want to, but they have to have that first email. Now, if you're ever only going to have at most two emails, maybe you have an argument against creating a whole nother table that you would have to join to because it's a needless complication, right? And so it's not, strictly speaking, it's not a huge violation of first normal form, but technically it still is. And if you do have if the design of your database or the problem you're trying to solve is such that you do have a one-to-many relationship, then that needs to be a separate table. Okay. Simply define another table to model any one-to-many relation. Right? And the many-to-one relation, that's just that's the same relation, just from the opposite perspective. Okay. Second normal form is that it has to be, of course, it has to be one normal form. If it's not first normal form, then it can't be the second normal form. The second normal form is that no non-prime attribute is dependent on a proper subset of prime attributes. Right? So the key here, the key here is that if you follow the design patterns that I was showing you, and you always have a primary key named after the table that's an integer, not null, auto-incremented, this gives you second normal form for free. Right? Using a PK auto-generated non-null key gets you second normal form for free. Right? You will never be in violation of this if you follow that design approach. Now, there are some instances in which you would want to define a key, say, to make a combination of fields unique, right? And you can do that, and we'll talk about that in a second here. But as far as for a second normal form, again, it's very illustrative to look at violations of these things. So one violation here would be a purchase record. Sounds familiar. May contain a customer ID and a store ID, right? That customer made this purchase at this particular store, and a store location, right? If the key is the combination of customer ID / store ID, then it violates second normal form. Why? Because store location is only dependent on one of those things, right? It's a proper subset, remember, is a subset that is not equal to the set. So if I've got ABC, ABC is a subset of that, but it's not a proper subset. AB would be a proper subset of that. A would be a subset of that. BC would be a proper subset of that. The empty set would be a proper subset of that, right? A proper subset is simply a subset that is not equal to the set. And in this case, we're looking at this combination of two elements here, right? This combination, but it violates second normal form because store location, does that have anything to do with the customer? No, the store exists without the customer, right? They may never even have been a customer if they had chosen to go to a different store. So you cannot have data that only depends on a proper subset of the key, right? But you can, of course, have key combinations, right? It is often useful and necessary to define combination keys, but keep them secondary, right? And we did look at how to create a key, a unique key, right? Looked at with respect to what did we do? A film, an EIDR, sorry, excuse me, right? We made that unique. You can create a combination of keys. All you need is a comma delimited list of values. So for example, up here, I'll put it in the notes so that we have it. Let's look at an actor here. An actor and a film. Can an actor, well, now I've stepped into it here because I was going to say, can an actor act in a film more than once? Technically, yes, because, well, Eddie Murphy can play 50 different roles on some, stupid film, or, but you can have multiple roles, right? You can play your evil twin, and so you have 2 roles. I don't think that you get double the paycheck, though, do you? Probably not. So, from that, say what? If you could be the producer, and then you control the paychecks, right? And then you can do what's called Hollywood accounting, and no movie has ever made any profit for tax purposes, right? Instead, what you do is you take the profits and then you roll them back into your subsidiary companies that paid for the catering, or like you pay 10 times the amount in catering, and then the film never made any profits, right? And then you don't have to pay anybody for, that's why you always get the gross and not the net, right? You never sign a contract for the net, because there is never a net, right? Through Hollywood accounting, right? That's actually a term. But anyway, we've got a film and an actor. We'll just say that an actor can't appear in a film more than once, right? So in other words, in our join table here, we don't want the combination. We don't want a combination of an actor ID and a film ID to appear more than once, right? Because that would be a duplicate record. What were we using? Robert Downey Jr., right, appeared in Endgame once, not twice, right? If we had Robert Downey Jr. appearing in Endgame, Robert Downey Jr. appearing in Endgame, Robert Downey Jr. appearing in Endgame, right? That would be considered erroneous or redundant data that we don't need. So what we can do is in our film actor table up here. Let me go ahead and move up here so that I can go to it. Where is it? Film actor. There we go. What we can do is we can modify this to have a key combination on those two fields, right? Not on the film actor ID, because that would be we've already got two normal form here. We don't want to screw that up. By having this primary key that's auto-incremented, we got two normal form for free. What I want is a unique combination on the actor and the film ID. And to do something like that, you can go ahead and add a key, right? So you can have a uniqueness constraint, unique key. I'm going to have to, unfortunately, I'm going to have to look at my notes here to remember the exact syntax of this. But let's see. I don't have it here. Unique key, combination on actor ID and film ID. Something like this, right? So I'm going to put in a note here, look up syntax. If anybody's online, they can look it up with the other notes and let me know how to fix that on the fly here. But you can have a unique combination, and here this definitely is the syntax for combining two things together, and the combination of those two things has to be unique. So the actor ID, the Robert Downey Jr. can appear in film A and B and C because each one of those is unique. But you can't, and you can have, what film was this? Endgame has actor A, actor B, and actor C because those are unique. But the combination of Robert Downey Jr. appearing in Endgame can only ever appear once by putting in a unique key on it. Right? Does anybody have no? Okay. I think it's also in the album database. There's a unique key on it like this. But I'm going to have to put in a to-do. To-do. Look up that syntax. Right? All right. So second normal form. Essentially, you split everything out into its own table. Right? And this actually goes back to Java itself. Right? Encapsulation. If I have a customer class, should I have store things in that customer class? No, it has nothing to do with the customer. Should I have customer stuff in the store class? No, keep those things separate. Okay? We don't use the term encapsulation with respect to databases, but it's the same exact idea. Third normal form is that it has to be second normal form, and by transitivity also, transitivity, there we go, first normal form. Right? Transitivity, A is related to B, B is related to C, therefore A has to be related to C. Right? Transitively it has to be a first normal form. And the statement here is that no non-prime column is transitively, there we go, I spell it right, dependent on the key. Right? So for example, and again, we're going to look at these with respect to violations. Suppose you had a price per unit, right, and a number of units. So obviously, what's the total cost here? Total cost is going to be price per unit times number of units, right? If you stored total cost as a column, it is a violation of third normal form. Why? It leads to potential data anomalies. We've got a price per unit, $10 per unit. I'm probably going to have to buy a new switch because I've repaired it as much as I can and it's on its last leg. So just a new switch is, and there's a rumor that there's a new Switch HD coming out in December? Yes? No? Okay, we don't know. Okay. I don't play Pokemon, so I don't know. But I have heard that there's a new Switch coming out, maybe $300, right? One Switch for $300. Number of units, $300. What if they go on sale right before Christmas? Instead of $300, so if I pre-computed this, it would be, or I wanted to buy 2 Switches because I didn't want to share. So now 2 times 300, that's $600. I'm storing $600 off into its own column. But now we've changed, right? We've changed so that we've got a sale going on. Now it's only $250. What's my new price? 2 times 250, $500. That does not jive with the $600 that I stored, right? So don't store that, right? If you need to compute the total cost, you simply just multiply them together. You can do that in an SQL query, or you can do that in the Java code once you've loaded everything up. Now, there might be an argument for saying that, well, when you made the purchase 3 months ago, it was $300. It might be $250 today, but 3 months ago when you made the purchase, there was $300 back then. In that case, you would want to create a kind of a temporal relationship where the purchase also had a date associated with it, and that date had a snapshot of the prices at the time. You still wouldn't store the total cost. You would just store a snapshot of all the prices that you had, the prices and the number of units that you actually had at the date of purchase. Right? Otherwise, it would be a violation of third normal form. The total cost is transitively dependent on 2 other column values, right? So we don't store it. We recompute it as needed. Okay? And so finally, there's this mnemonic device that is often used. And for the bottom line is third normal form is kind of intuition, right? When you're it goes back to object-oriented programming. When we design our objects, semantics dictate design. If you want to support the fact that you have multiple emails, that's a huge red flag there that you should have a collection of other objects. When you design a sale, that's a huge red flag there that you should that it should own a list or a collection of items that are on that sale, etc. Right? When you design a salesperson class, then they should have track all of their sales. So there should be a list or a set or a collection of sale objects for that salesperson, right? And we'll talk about that here in a second. But bottom line, it's basically semantics dictate design. And the mnemonic here is based on the inventor of the relational database model, Edgar Codd, that every non-key attribute must provide a fact about the key, first normal form, the whole key, second normal form, and nothing but the key. So help you Codd, right? And are you telling the truth, the whole truth, and nothing but the truth, so help you God, right? That's where it's coming from, right? It's a fact about the key, first normal form, so that you are splitting things out into their own tables. Second normal form, nothing but the key, so it doesn't depend on the store. And third normal form, the whole key, that's second normal form, and nothing but the key. Total price has nothing to do with the key. It's transitively dependent on the other non-prime attributes. Okay. Again, there are other normal forms. A fourth, fifth normal form, and a bunch of other things that are built on top of it for temporal databases and stuff like that. Don't worry about those things. Right? This is basically all you need. So, miscellaneous stuff. Right? There is a lot more to learn about databases. relational databases and data modeling, right? You've got, for example, triggers, views, stored procedures, variables. Somebody asked about that on Piazza, and yes, there are variables, but you are discouraged generally from using them. But if you're a DBA, you'll use them on a day basis. Triggers are something where you can set up a procedure. Every time this record is a record is updated in this table, shoot me, that's one such trigger. Or every time this record is updated, update the column that says last updated with the current date and time, right? You can do triggers like that. You can do views. Views are read-only select statements. So if you want to, you can go ahead and pre-compute a bunch of table joins and give access to, say, an application or a particular user that is only ever intended to read from the database. And this is a good way of separating concerns. That if you have a team that is writing all the web pages that display all the data or something like that, don't give them full unfettered access. Give them access to views. What data do you need? We need this data, and this data. Okay, you don't need that other data, so I'm not going to give it to you. Right? I'm going to build this view for you, and you can query it all you want and get those 3 pieces of data that you asked for. But you can never insert anything because it's not a real table. It's just a view, right? It's a particular view. I don't know another synonym for it, but a look at the database, right? Stored procedures are basically functions that you can define and store in the database and execute those functions as you would, say, a table or something. And of course, you do have variables. It's generally limited to what are called transactions. Right. Transactions are an all or nothing query, a series of queries. Right. So for example, say that you want to insert these 3 pieces of data. But these 2 pieces of data depend on this piece of data. So what you can do is you can wrap these 3 queries up into one transaction. And a transaction is an all or nothing thing. You start the transaction, the first one executes, the second one executes. The third one fails because of some data anomaly or some integrity violation, or you have bad SQL syntax or something like that. It's like the first 2 never happened. The entire transaction gets rolled back and it never happened, right? That goes to the ACID principles, atomicity. C is consistency, isolation, and durability of relational database management systems. This is all based on transactions. It's an all or nothing series of queries. Right? Now, by default, each query is its own transaction. So to start a transaction and then commit a transaction or roll back a transaction, that's syntax that I've not covered, and it's not cross-platform either, I believe. But if you do it in MySQL, it's like begin transaction, right? And then query, 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 commit transaction, or roll back transaction. Or I think it might just be roll back. Roll back means undo everything that was in this transaction, right? But it's an all or nothing series of queries that you can use to protect yourself. These 3 things, all of them should happen or none of them should happen. Right? You also have security issues. Right? Do not store sensitive info in a database unhashed or unencrypted. Right? For example, passwords. Passwords should not be stored unhashed in any database. Because the most vulnerable, and once you've got the database, guess what? The entire system is compromised, not just the database. Password, you put it through a cryptographic hash function. So my password, PASSWORD, it's not my password, but that's the most common password. It gets hashed as this big, long hexadecimal string, right? You store that hexadecimal string. The next time somebody tries to log in, you say, give me your password. Okay, they type the password, PASSWORD, and then you rehash it, and does the hash match, right? Does it hash to the same thing? You use a powerful cryptographic hash function. You don't just use some blind garbage hash function like, say, MD4, MD5, or even SHA-1 is retired now. But it's the most common error because people get into databases all the time. Once they do, even if you've got a weak hashed passwords, then you can start doing what are called rainbow attacks, where you take a list of the 10,000 most common passwords you pre-hash them all to see what it would look like, and then you look at the database. Is that one in there? No. Is that one? Oh, yes, it is. Okay, well, what does it map back to? Oh, they use their password 1234, right? It is the most efficient and most easy and most common way of attacking systems. Don't store those things in a database, right? In fact, I wouldn't even store a powerfully hashed password in a database anymore. It's more common now to use single sign-on services, right? More and more nowadays, you don't even sign into a website anymore, right? They say, oh, you can sign in with your GitHub account, or you can sign in with your Gmail account, or you can sign in with your Facebook account, right? All they've done is taken the problem of solving security and passed it off to Google. So as long as you trust Google with your passwords, you can trust that other website with your passwords. Because it's a single sign-on service, you're redirected over to the Google services for authentication, and the authentication ticket comes back to whatever website you're trying to get into. Right? All right, so there's a lot more than that. You could have soft versus hard deletes. And this is something I mentioned not because it's common, but anytime I've developed a real system in the past, I've always put in soft deletes. So a hard delete is a result of a delete statement. In other words, it's gone, right? Somebody comes in, they hit, I want to delete this record, right? From the user interface. They hit the red X button. And you've designed your interface well because this is a dangerous operation. Are you sure you want to do this? Yes or no, or yes or cancel. They click yes. Right? They really actually did not mean to do that, despite you putting in 2 levels of that. GitHub is a great example of this. If you want to delete a repository, first of all, it asks you, are you absolutely sure that you want to do this? Are you absolutely sure that you want to do this? If you are, you have to type out the entire name of the repository for me to delete it, right? So it's not just a simple click, because you can always, fat finger clicks or double click or something like that. So you actually have to cognizantly sit there and type out the entire name of the repository in order for it to get deleted, right? Still, people make mistakes, right? But in a database with MySQL, of course, once you delete something, it's gone. Unless you have a database backup somewhere from last night or from a very recent database backup, it's gone, right? That's a hard delete, right? A soft delete involves defining a Boolean column. Usually it's called isActive, right? Active. That is true if the record is active, and false if it is deleted, right? And I put deleted here into quotes because it's not really deleted, right? Your user interface will only pull records where is active equals true, right? And so you're only displaying the active records. So that when ID10T user comes in and deletes, yes, I absolutely want to delete that. Yes, I'm going to type out my password to delete that, delete. I didn't mean to do that. Then they come to you, the system administrator or the designer, and say, I didn't mean to do that. We lost all our sales for the last 10 years. Right? Can you help me? Do we have a database backup? I don't know. Let me see what I can do. And of course, you sit there and you twiddle your thumbs. You go play some video games for a while. And then you come back and all you do is set that one column value to active to be true. And then you're the hero, right? And they're none the wiser. We call that Scottying it, right? Scotty from Star Trek, right? He always said that I need 10 hours to get the engines back online. Well, you only have 2. Okay, I can do it in 1. Right? You always give an overestimate so that your abilities, that you look like Superman to the normies that don't know how to do this kind of stuff, right? There's also an issue of the object model versus the relational model. OOP model versus relational model. So with both of them, you have pieces of data, but only with one of them do you have behavior and inheritance. Right? An OOP model allows inheritance. That you can create a class from another class, a subclass with specialized behavior or additional pieces of data. Now, that wasn't really, that doesn't really, it isn't really compatible with a relational database system because relational database systems don't have that concept. They don't have inheritance. RDBMSs do not have inheritance. They just have tables. You need a way to resolve the difference in these two models. Because if you're going to be, say, storing a subclass, like, say you've got items and subscriptions and what else do you have this year? Products and what else? Services, right? Those were the obvious subclasses that you should have created. How are you going to store those in a database when you don't have subclasses? And there are lots of ways that you can do this. You can create a table per class, right? Per class, subclass, right? That's one strategy. You can create a table per stub class, right? In other words, only one table per subclass that has no subclasses, right? So all the we call them stubs because that's where the inheritance ends. If you've got if you've got a grandparent, parent, and then a child, you would only create a table to represent that child. You would not create a table to represent the grandparent or the parent. You'd only have that one last stub class. Or the one that I'm going to suggest that you do, you can create one table for all subtypes and use a discriminator column. There we go. That sounds familiar. That's exactly what we did in your CSV files. How do you tell the difference between a service, a product, and a subscription? The type, right? The type column. I think we used SU for subscription, SE for services. I don't know. There we go. Subscription, whatever we used, that was the discriminator column, right? You were using that string value to say that this type is a certain subtype. You use a string to indicate the subtype of the item or of the class, right? Some columns may be relevant to some subtypes. Others may be irrelevant, right? Relevant ones, well, in any case, relevant, there we go. Simply allow them to be null to allow to model this, right? So, for example, subscriptions, they have a begin date and an end date, right? If this particular record was a service, there is no begin date, there is no end date, so those would be allowed to be null. And for that particular record that represents a service, they would be null, right? Otherwise, you would store a whole bunch of columns. Some of them are going to be relevant, some of them are not going to be relevant, depending on the record that is being stored. Okay, and that's we recommend that one simply because it is the simplest way of handling it. You can go ahead and use a table for all subtypes, or a table per class, subclass, or you could use a table per stub class if you wanted to. You're going to, not exponentially, but you're going to quadratically blow up all of your work when it comes to actually querying out of your database. And that's why we recommend using a single table inheritance strategy, right? That's what this is called, right? You can use a single table inheritance strategy. And that's what we recommend. Of course, if you want to go your own way, there are perfectly valid other design options out there. In fact, in your design document, you can talk about them. We initially thought that we would have a table per class strategy, but decided that it was overly complicated. And since we only have really 3 or 4 or 5 subclasses, it doesn't matter. And we used a single table inheritance strategy. That's the kind of thing that should be going into your design documents, that you considered this. Why did we decide against this? Because Dr. Burke said, don't do it because it is too complicated. No, that doesn't belong in a design document. You give the justification that I just gave, that it overcomplicates the problem, right? All right. Any questions on databases? No? That string could also be an enumerated type if your database supports it. We will be talking about, it's screwed up on my YouTube, but all right. So what I wanted to do now is I wanted to go back to everybody. We're still grading assignment 3, which is the second phase of your project. But what I wanted to do is I wanted to run through the issues that I posted on Piazza, a few of them, and discuss what I meant by that with concrete examples. So I've got a project set up here, first of all. In your project, you have several items. So for the most part, the inheritance strategies that we saw, where you've got an item and then you've got subscription, service, and product, right? That's a simple inheritance. We saw that a lot. Some people chose, and like we did, to further have an inheritance for the product, because there are 3 different types of products, right? There's new, there's used, and there's a gift card. Some people chose to make it into 5 classes, all at the same level. Some people chose to do a whole bunch of other things. All of those are generally perfectly fine as long as you're following the good inheritance strategies. So what I'm going to do is I'm going to do just one class here. First of all, let's go ahead and make a class. At the very top here, what did people have? What did you have? Anybody? Item? Okay. Item. Tell me about an item. Now, this is semantics dictate design. When you start creating these things, what does an item have versus, say, what a subscription has? So a subscription, do all items have a begin date and an end date? No. That belongs in the subclass, because that's a specialized behavior. That's a specialized data. But what is common to all objects? What is common to all items, I should say? They have a code, right? Which is a string, right? What else do they have? A name, okay, which is also a string. What else do they have? Honestly, I don't remember. Yeah, so what is cost? Cost is behavior, right? Because a subscription is based on the begin date, the end date, and divide by 365 times the annual fee, right? Versus a product which may have an 80% or 20% discount if it's used, and also you could have 3 switches and they each cost $250, so you need to multiply those together, et cetera, et cetera, et cetera. Right? But what's common to everything? So that is behavior commonality. Let's talk about that in a second here. I thought that there was a third thing. Oh. Oh, okay. So lots of people did this, string type. And for the first phase, that makes sense because it's a discriminator column. We didn't ding anybody for keeping this, but at this point, you don't need that. Why? Because once you use inheritance, the class itself is its type. You only need that string in order to determine that I need to create a subscription or I need to create a service. So, string type to do, consider removing this. Right? Consider, right? Why do I say consider? Well, it may be necessary if you want to save it to a CSV file or persist it to a database, right? In any case, this is the only data that is common to all items. I'm going to make these public void or public final. Why did I make them final? So they can't be changed. Prefer immutable objects to setters and mutable objects. So we never took off for it, but we still saw people using setters all over the place. And they got into trouble because then they saw the setters and they were really once they're there, it's really tempting to use them. So when you've got a gift card object and you put it on one sale for $50, I have that same gift card object. Oh, I'll call the setter and make it for $100 now and put it on sale B. What did you just do? You changed the original sale, right? So I'm going to make these final, and I'm not going to generate any setters. Source, generate getters and setters, but I am only going to do getters. Right? There we go. Because that's where my cursor was. All right, there we go. Right? Come in. Oops, no. Reformat that. There we go. Remember, formatting, auto-formatting. We're not seeing that many issues, hopefully because people are using Shift-Command-F or whatever Windows is. Okay. But what else do I need here? I need a constructor. And all of those fields have to be specified. Excellent. Now I've got a way to create items. Let me go ahead and create a new class here for demo, and I want a main in here. Let me go ahead and create one for the Switch. Item I is equal to new item Nintendo Switch. So Nintendo is, yeah. Oh, I was just going to go with 9-inch nails. Nintendo Nin Switch. There we go. Nins. I don't think that stands for anything, but its type is going to be a new product. I don't know if that's what we did. Product new, TN, new. All right. And it's a Nintendo Switch. Yay. All right. Now, has anybody actually purchased this thing? Is there a price on it? No. Right? Because not all items have, a lot of items have a base price. We could have redesigned this, and it's perfectly acceptable to put in a base price up here. Public final double base price. Right? This makes sense for, say, most of the things. And the one thing that it doesn't make sense for is gift cards, but you could always say that the base price for a gift card is 0 if you wanted to. Right? All right. Should I be able to create this? I don't know. Another thing that it was perfectly acceptable would be to make this abstract. Right? In which case, no, you cannot make that. I'll go ahead and get rid of this. I won't get rid of it, but I'll comment it out. Why would you want to make this abstract? Now let's go back to your observation that everything has a price, right? Everything has a total price. Public, double, get total cost. Instead of price, let's call it cost. Get total cost. Right? Now, what's a total cost? A total cost is going to be whatever it costs. You know, if it's a product like a Nintendo Switch, it's base price because it's new, not multiplied by 80%. But if I want 3 of them, well, then I better multiply that price by 3. But also, I've got some taxes in there, right? And products have a tax rate of something, 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 right? So what else? And why did I make this abstract? Well, once I typed the keyword there, abstract, because the total cost is a specific behavior that is specific to each subclass. Subscriptions do it differently than services and products. They all do things differently. There's no way that I can compute this. But there is a way that I could compute, say, I mean, there are some variations that you could do here. What could I compute? Public abstract double. Maybe I could get the total cost. Let's not make this abstract. The total cost is, what did I say? The cost, this dot get cost, plus this dot get tax. Right? And that could be a common behavior among all my things. It's just that the get cost, that's what's different. That a subscription is done differently than a service. That would end up being an abstract method, right? So let me go ahead and put that in here. Get cost, and that will be abstract. But also get tax would be abstract. Why? Because it's different rates, I think, for like a 7% sales tax rate for products, 0 on gift cards, or 0 on subscriptions. Yeah, something like that, right? So get tax or get tax rate, right? That might be helpful too because everybody has a different rate, right? And then the tax rate is, then I could compute the get tax, right? What could I do here? This dot get cost times this dot get tax rate. And that's the total tax, right? It all depends. You didn't have to do it this way. You could have made this abstract, and then you would do it in this class, and this class. But then you'd quickly realize, wait a second, repeated code, repeated code, repeated code. That should go in the superclass. Right? What you absolutely do not want to do is once you've got an item I, right, whatever that is, you absolutely do not want to do this if I is get type is equals content equals product new, right? Then compute the totals here, right? Else if, and then I dot get type If it's a subscription, you said SB, then do something to compute the total here, right? This is completely antithetical to all object-oriented programming. This is what you do when you don't have objects, right? You have a bunch of switch statements, a bunch of if statements. The only time that you want to do something like this is when you need to do something like this, when you need to create something. You're loading something up from the CSV file. Oh, it's a product new. I have to invoke a specific constructor. I have to call a new product, right? If that's what you did. Here I have to call a new subscription. And I'm not filling these out here, but you get the idea. And it's perfectly fine to do it like this, but not to drive the business or the business rules defined by the project. Right? Let's do one more class here and see what it looks like. Right? Let's just do subscription. There we go. Or a couple more classes, I guess. So a subscription is going to be extends item. Now tell me about a subscription. What in addition does a subscription have? An annual fee, right? And again, you could argue, well, everything has a base price that you put up here. An annual fee is the base price. You could go, it's perfectly fine. This is what we talk about. There are some designs, there are multiple designs that are acceptable, right? And if you did that by putting it in the item and called it base price or something, that's perfectly fine, right? Why are you complaining? Oh, thank you. Not anymore. All right, so an annual fee. What else in a subscription? What if you did this? Double total cost. Right? And when you created this subscription, you took the date, you computed the number of dates, divided by 365, and then you multiplied it by the annual fee. You took that value, and then you put it into the class. What's wrong with that design? All that stuff that I just said, of date, differences between them, divide by 365, multiplied by this thing, that sounds like subscription stuff to me, right? And if it's not in the subscription class, that means it's somewhere else, outside the subscription class. Encapsulation is three things. It's the grouping of data, the protection of data, and the third, most important in this discussion, is the grouping of behavior that acts on that data. That certainly sounds like behavior that acts on that data. Where does it belong? Right here, right? So I'm not going to store the total cost. What am I going to store? I could store int number of days, right? And then I'll, days, there we go. And then I'll allow the subscription to say number of days divided by 360 times the annual fee, right? That still requires me to compute the number of days outside the class. Not only that, but I don't have good modeling here, right? What do I lose by computing that outside of the class? When it started and when it ended. I lose information. Say somebody comes into my game store and says, oh, I bought a subscription to Nintendo Online, but I need a refund because my grandmother gave me one for my birthday and I don't need two, right? Oh, happy to help you with that, sir. Do you have a receipt? Oh, okay. This receipt says that your Nintendo subscription was for 365 days. When did it start? Right? Well, I purchased it on this day, and I have that information, but I actually started it. I haven't started it yet. Right? How do I know that? Right? I only have number of days, so I've lost a lot of information. How do I know that you didn't, or that this is from 3 years ago? Right? Say. I don't know why they would be coming back 3 years later and want a refund on a Nintendo subscription. How do I know that they didn't already use it and then it expired and now they're trying to get money out of me, right? If I lose that information, there's no way that I can determine when did the subscription start and when did it end. Right? This is not the correct modeling. What do we want instead? Local date. That's what we demonstrated in class with the date time library. You could also use date, the old school Java way, I think, or Joda date time. Some people chose to use that from lab 1. Local date begin date, and local date end date. Right? And I'm going to go ahead and import these. At this point, of course, I would make these public or private, final. And I would also generate getters and setters, as well as what? Constructor. What does a constructor look like? If you just generate it, that's what it should look like. It calls the super constructor, handing off the code, the name, and the type. So that the super constructor, super, is responsible for that stuff, right? It's still not compiling here. Why? Well, we've got abstract methods that we've not implemented yet. So let's add those unimplemented methods with actual, behavior here. So what is the cost of a subscription? It's from this date to this date, divide by 365, multiplied by this annual fee, right? So this dot begin date dot until, until this dot end date, and then the temporal units here will be days. I don't know if I can get away with this, can I? No. Chrono units dot days. There we go. And I have to import that, I believe. Chrono unit. There it is. There. All right, that gives me the number of days. Now remember that if you read always read the documentation, because if you read the documentation, it'll say that the end date is exclusive. So if you've got a week, then it'll only give you 6 days because that end date there is not included in that, right? So what I need to do is I need to add one, right? And that'll get me part of it. I need to divide that by 365, right? And times this dot annual fee. Okay. Now, if you look really hard here, you'll realize that there's going to be a problem. Until returns what? A long, divide by an integer, and you get what? Long is an integer. So integer divided by an integer is an integer. So what should I do? 0.0. That's one trick. Or you could typecast the numerator by double, etc., right? That's the easiest way. Right? What's the tax rate on a subscription? Do you remember? Oh, is it 0? Okay, hey, excellent. Done. Now, technically, you should do 0.0, right? Another trick here that you may eventually need to use is to put an L next to this. It's not necessary here. I don't know why it's at least not complaining with a warning about it. But a 1, an integer 1, and a long 1 are not necessarily the same things. So for example here, I'll go with a long foo is equal to 2.147 billion, 123, right? That's going to work fine because, of course, that's an integer and it's smaller than it's certainly small enough to be fit into a long here. But if I try to go up to 5 billion, wait a second, that's... A long is certainly large enough to hold 5 billion, right? An integer is not big enough to hold 5 billion. So what's wrong here? When you type a literal like this, the default is to interpret that as an integer. This is too large to fit into a 32-bit integer. So what I do is I put an L next to it to tell the compiler this is not an integer, this is a long integer. And so now 5 billion is certainly small enough to fit into a 64-bit 2's complement signed integer, right? So you might see some of these L's somewhere, right? You can also use, I believe, D, but I'm not sure, for doubles, right? Or F's, right? Float bar is equal to 3.14 F, right? That, otherwise, I believe the default is to be a double, right? That's just a little bit of a trick there. A lot of programming languages support that, okay? All right. So let me go through my list here. Bad inheritance needs to be fixed. Again, if you find yourself doing a bunch of if-else-if statements, you're violating the open-close principle because it's now it's closed for extent, or you're opening it up for extension, right? You're imagine here's the scenario. Imagine a new type of product comes along that you want to support in the system, right? Anywhere you have this big chunk of if-else-if statements, you now have to add this new type of product, right? Another product comes along. You have to add yet another if-else-if condition there, right? And so everywhere you're doing that, everywhere you're doing taxes, everywhere you're doing totals, everywhere you're doing whatever, all of that code has to be touched. but if you follow this pattern, all you need to do is create a new class, override the methods here, and you don't have to touch any other piece of code at all. All the code that summed up all the totals, that still works. Why? Because you extend the original item here. Right? You only ever deal in items. And that's why it's so important to have your interface well-defined up here. That this should be well-defined enough to handle all the current types of products that you have and then all the future types of products. Everything going forward is going to have a cost. Right? So that's clear enough. You should also have good modeling. So for example, let me go ahead and create a sale. Right. Now, is a sale an item? No. What is it? It's a collection of items, right? Well, first of all, what is a sale? We're selling it to a particular person, right? So we should have a person class somewhere, and that's the customer. But what other kind of persons do we have? A salesperson. Right? What else? You also have a store, right? A store. Right? So you probably need at least a person object and a store object. What do both of these things have in common? They both have an address. So, but are they an address? Probably not. So in this case, these are not related by inheritance. They're related by composition. A person owns an address. A store owns an address. Right? I don't have these defined here, but one thing that we saw commonly was string, strong, and string. Is that correct modeling? A person is not a string. Right? A store is not a string. It contains strings, absolutely, but it also contains an address. It contains all of those things. To model it like this, you lose information. Right? If you modeled it like this, there was no way that you were going to be able to get the bonus of ordering all of the stores by the manager, right? Or ordering all of the sales by salespeople, right? Because these things should own references to those other things, and without it, how can you possibly? I've got two people here, but I don't have any sales records, right? This salesperson, I need to know whether or not, sorry, I'm doing. I should have done stores first, but you get the idea. How am I going to order these things if all I have is their code? Right? If I wanted to order a bunch of sales by the salesperson, I can't. I can't do it by last name, first name. I need to model this properly with a person object, and a store object. Right? And of course, that's to do, right? But what else is a sale? A sale is a collection or a list or a set of items. Right? And those are items on this sale. What I'm going to do is I'm going to go ahead and get rid of these for now, and I'll put in a to-do. To-do, finish this up. Right? ... Right? Do you want a list or do you want a set? List, not a let. It doesn't matter, right? Because what I want to do is I want to make sure that this is not a leaky abstraction. So I'll go ahead and generate a constructor here, and I'm not going to select any of them. Right? So normally the sale constructor here would of course take a person, customer, person, customer, person, salesperson, right? Store, and the code or whatever else you need here, right? But for now, I'm going to leave these off because I've left those off up there. But what it's not taking is a list of items. What I'm going to do is I'm going to make this a little bit more versatile. You can create a sale and then add the items to it as you go along in your processing. So for example, I could have a public void add sale, and it takes this, or not add item, and it takes an item. This dot items dot add I. Now I'm going to have to make sure that this compiles. And in my, of course, you need to instantiate this. This dot items is equal to new array list. of items, right? Now it'll actually work once I import this. But look at this from the outside world. Right? I want to create a sale over here. First of all, I'll just add this dummy item right here, okay? S is equal to new sale, right? And I'll add it, s.add. Oh, do I need to worry about if it's a set or a list now? All I do is add it, right? What if I needed to, what if I did something like this? Dot get item list, right? Dot add I. Does that look as clean? If I had a getter for that thing, and then you added it to the list? No, not at all. Not only that, but it is a leaky abstraction in that you give me the list, and now I need to know how to deal with a list, right? It's easy enough to add something to the end of the list, but maybe it's a sorted list, and I need it to be comparable or something like that. Maybe I have, maybe it's, maybe there are some special rules for me to call here. I shouldn't have to worry about that kind of crap, right? I'm just going to add the item. Sale, you're the sale. You're responsible for sales stuff. Here you go. Here's an item, right? Add it to your list, right? Sorry, add item. Let's add item. There we go. Before it was a leaky abstraction because it forced me to deal with the internal workings of that class. Now, if you did something like that, I don't think that we dinged you too much, but certainly the biggest problem here was that people didn't even have sale items in a sale. How do you know what's the total of the sale, right? If you're not storing the items. What they were doing was they were computing it outside the class and then giving that, or hopefully they were at least giving that to the sale class to store. A lot of times they wouldn't even do that. A lot of times they would just print it out in the report and that was it. Right? What about a salesperson? What else would own a list of stuff? Let me go ahead and create a salesperson class here. Now you didn't have to necessarily inherit stuff. You know, you could have a person, and then under that you could have employee, gold customer, platinum customer, or you could get more elaborate. You could have person, employee, manager, and then over here you could have customer, and then under that you could have platinum customer, gold customer. There are lots of combinations that you could go with. I'm just going to go ahead and go with a simple salesperson here. How does a salesperson track their sales? A list of sales. Right? A lot of people didn't do this. And so how could you know that this salesperson, what their total sales was for that summary report? Right? Likewise, what does a store look like? The store should also have a list of sales, right? Etc. Right. None of this is compiling because, of course, it's incomplete. Proper composition, proper data modeling, loading, of course, loading in separate classes. Remember the single responsibility principle. That permeates everything here. A sale should not have to be responsible for customer stuff. It owns a customer, and it asks a customer or a person, what's your discount rate, because that is necessary for the sale, but you don't store that in the sale class itself, right? That's a function of a person. Right? Put stuff where it belongs. So anytime you write a line of code that's acting on data, ask yourself, what data am I acting on? I'm acting on sales data. Then where should I be? In the sales class. I'm acting on customer data. Where should I be? I should be in the customer class. Right? I'm acting on subscription data. Where should I be? The subscription class. Right? And if you did something like that, then your sales report, like the main in the sales report, should probably just be like 6 lines of code or so. Right? For example, a summary record. Where would you put that? The suggestion that we had all over the place was in the toString method. Right? And here, produce a detailed sales report for this sale. Right? Why? Because then over here in your main class, I don't know why you're complaining, but whatever. Then what would it look like for like a list of sales here? All sales. Right? And I have not instantiated that yet, but for sale S in the collection, all sales. If you did it in the toString method, what does it look like? It's one line of code. That's it. Right? And of course, I've already used S here, but you get the idea. That's all your detailed report should look like. And it's complaining because it hasn't been instantiated. Fine. New array list. There. All right. That's the detailed report right there. The summary reports, that could be a function of the toString method in a, let's see, a store, right? Because you're doing it by store, or an employee, right? Their toString method. There it's a little bit less clear because sometimes you need to print out a person, so a person's last name, first name, and then their emails and their address or something like that. So there are lots of acceptable variations there, but certainly sales stuff should not belong in the salesperson class and vice versa. Subscription stuff should not belong in your data loading class, where now you've got a God class where you're producing all the reports and figuring out all the numbers in your data loader class or something, or your sales class. All right. I mention this because, again, you have a little bit of downtime because you have 2 weeks before your database design is due. Take a little bit of that downtime to go back and fix these issues. Because if you don't fix an issue like this, there's no way that you're going to be able to get the bonus going forward. How do I order stores or employees if this data is not in that class? You'd have to roll your own sorting procedures, and that's really, really bad, right? But if you've got a salesperson class here that is comparable, implements comparable salesperson, and that comparable interface there simply just does it by last name, first name, there's your bonus from the previous phase, right? But yeah, like I said, one thing you have to remember, you've got to find time to do it right the first time, or you'll have to find time to do it over. What you've done, we'll talk about this later, it's called technical debt. If you had a bad design on this phase, that means that you took a loan out on your future time, right? That your future time now is going to be spent fighting your design, or your future time is going to be spent going back and redesigning it so that you're not fighting it, right? That's why we call it eating your own dog food, right? If you, that's why parents, if you've got a cookie and you have to split it with your brother or sister, right? You say, okay, one of you gets to tear it in half, and then the other one gets to choose which half they get. Why? Because otherwise you just tear off a piece and there's your piece and I get the whole cookie, right? If you have a bad design, then that's what if you tear the cookie wrong, you got to live with it, right? The sibling is going to choose the larger piece. So if you design dog food, you're going to have to eat your own dog food. All right. I don't see any questions online here. About 86 in attendance today. Good. All right. Then we will continue with database connectivity next time. In other words, how do you write a Java code to actually connect programmatically to your database to pull stuff so that you're not using MySQL Workbench, right? You want automation. You want your program to interact with your database rather than just doing it through an IDE like MySQL Workbench. Okay. All right. See you on Thursday.